For this video, we are going to be discussing independent and dependent variables. So let's discuss what those mean. In every relation, there's going to be an independent variable and a dependent variable. And the independent variable is just what goes into the relation. We can also call it the input. The dependent variable is what comes out of the relation. We can also call that the output. It's very simple. Independent variable goes in, dependent variable comes out. So let's look at a table that might show you some different words that'll help you understand this. An independent variable can also be called the input. It is also always going to be what we'd consider the x value. X value always goes in, and it's also always going to be what we consider the domain. All right? So similarly, the dependent variable is also the output. It's also what we'd call a y value. It's also what we'd call the range. So if I gave you an example like y equals 2x plus 3, all right, whatever y is dependent on what we put in for x. If I put y equals 2 times, let's say x is 3 plus 3, well, if I work this out, 2 times 3 is 6. 6 plus 3 is 9, so I get y equals 9. So y is 9. But if I say y equals 2 times, let's say x is 5 plus 3, well then 2 times 5 is 10, and 10 plus 3 is 13, so y equals 13. You can see that y depends on what x is, meaning it is the dependent variable. If I made a table of these, over here I've got x, and over here I've got y, well, I would say my x values are 3 and 5. My y values that go along with them are 9 and 13. These are independent. These are dependent. All right, it's always independent is what goes in, dependent is what comes out. So let's take a look at some examples with some word problems. Example 1 says, determine the independent and dependent variables in the problem below. Oh, maybe. All right, it says, an experiment showed that as time increased, the height of a plant also increased. Okay, so let's think, what is going in? We're saying, if we look at the table, as the amount of days goes up, the time goes up, the plant height is also going up. You can answer this question pretty simply and ask yourself, does time depend on anything? Is there anything making time go? The answer to that question is no. Time is always independent. So we're going to say our independent variable is going to be time. And that means that our dependent variable is going to be height. All right? As time goes up, so does height. All right? And that's all we have to do. We know time is what's going in, height is what's coming out. All right, let's try another problem. Determine the independent and dependent variables in this situation. It says the dance committee is selling tickets to the fall ball. The more tickets they sell, the greater amount of money they can spend for decorations. So here are our two variables. It's the first thing we need to figure out. Tickets and money. Those are our two variables. We have to decide which one of these is the independent, which is the dependent. Well, let's think to ourselves here. What is going into this problem? Are we saying they have more money, so they sell more tickets? Or are we saying they sell more tickets and that means they have more money? Obviously, the second choice makes more sense. As tickets go into the machine, all right, we sell more tickets. What comes out? Money, all right? So tickets are our independent variable. And money is, oh, I didn't spell that at all correct, independent. And money is our dependent variable. All we got to think is that as tickets get sold, money goes up. All right, so that's all there is to it. So your try-it problem for tonight is to determine the independent and dependent variables in this situation. The longer you spend studying, the higher your test score will be.